paper at the back. If you did not, you need to get it.
Are we going to have COVID?
You will only have 7 minutes to complete it.
The whole thing?
Yes.
7 minutes.
You actually have less than that because you have to have it turned in to me before the timer goes off. So you're down to 6 minutes and 40 seconds now. As soon as you finish it, go ahead and get it turned in to me. And I will trade you for today's notes page.
Is this okay?
Mm-hmm.
Oh, that's. We forgot how to do this stuff.
That's why I'm reviewing it right now. Will you close the door behind you? So this page right here is not in your notes. This is just a recap of some terminology that you might need a refresher on for some of the definitions and stuff today. So a term, when we're talking about a term, we are talking about things that are separated by plus, minus, and equal signs. So in this case, this very first one, I've got two terms because I've got 2xy plus 5. So that expression is a two-term expression. This one has 3 terms because it's got 3x squared separated by a plus sign and 5x, and 5x and 9 separated by a minus sign. We have words that we use specifically when we are talking about expressions based on how many terms they have. Okay? These are all called nomials. Okay? And when it's 2 terms, we call it a binomial, remember? And when it's 3 terms, what do we call it? Trinomial. Mm-hmm. When it's 1 term, one is monomial, and then 4 or more terms is polynomial. Okay, so this prefix right here, we've talked about before. Okay, so those prefixes are just telling you how many terms are in your equation or your expression. Okay, polynomial is used as a generic expression when you're talking about any kind of nomials in a plural setting. Okay, so even if we have a whole bunch of binomials, if there's any of them at all that are polynomials or trinomials or monomials, we just call them polynomials when we're talking about them all together. Does that make sense? So that's all that the word polynomial is. So on the top of your notes page, it says polynomial sums and differences. We actually did this back in unit 1, 2, okay, back at the beginning of semester 1. And so we're just refreshing today some things because y'all have struggled with this and get more math again when that you had to combine your like terms, or do the perimeter and you had to only combine terms that matched. Okay. The other vocabulary that we need to talk about that we really haven't talked about to this point, okay, is the word degree. When you hear the word degree, most of the time you think that we're talking about temperature or the degrees of a triangle, right? Or the corners of a shape, okay? The measurement. Okay, when we're talking about the degree of a monomial or a polynomial, we are talking about the exponents. Okay? Particularly the sum of the exponents that are on the variables or the highest exponent if there's not a multiple variables altogether. So notice in these first three right here, okay, the monomial, the degree of 12 is 0 because there's no variable there to have a power on. The degree of negative 9x squared is 2 because the only exponent that you have is 2. The degree of 4x is 1 because there's that invisible 1, exponent of 1 on the x. The rules change if you have multiple variables in any term. Okay, so if you have multiple variables, then you have to add your exponents together. So in this one over here that has x squared and y to the 6th, the degree is actually 8 because you add all of your exponents together to figure out what the degree is. You don't really need, the only thing that you really need to know is when it's asking you to put it in standard form, or it's asking you to put it from least degree or highest degree to least degree. It's just asking you to put it from the highest exponent to the lowest exponent. Okay, so don't let the word degree confuse you or make you not be able to do it, because all it's asking you to do is put it in what we call standard form from the highest exponent to the lowest exponent. Okay. So when you're talking about degrees of a polynomial, okay, then it's the same thing here. We only care about the highest exponent. From all of those terms, the highest exponent is 2. So the degree of this polynomial is 2. The degree of this polynomial is 3 because that's the highest power on all of those. And those are really the only ones you'll be working with, are the ones that have a red dot beside you. Something like this, you might show up, okay? Rarely, you're not going to be asked to know what the degree is on any of these. It'll be more of in the directions it will tell you to write it in the degree, the proper format or something. Yes, Cutter. Can you hurry back?
Yeah.
So on the top of your notes, so when adding and subtracting polynomials, combine like terms. You need to make sure that you remind yourself that like terms have the same base and exponent. Okay, so when we are talking about combining like terms, you are just combining things that have the same letters and exponents that match. So in this first review on here, I've got a negative 3a, and the one that matches it is a positive 4a. So what is negative 3a plus 4a?
1A.
Just 1A. Right, the opposite sign, so you're going to subtract them from each other. Right, and then I've got a positive B and a positive 3B.
4B.
So plus 4B. And then I have a negative C and a negative C. Negative 2C. Okay, so that is what you were doing on problem number 1 on that skills check. Okay, the very first problem, you were just combining those two x terms to get negative 6x. So skip down to that third one. I've got 7x squared. Is everybody done filling in the blanks so I can zoom in a little bit?
Yes.
Okay. So negative x squared. Do I have, or sorry, 7x squared. Do I have another x squared term that I can combine to it? Okay, so negative 4x squared. And then x squared. So remember, they stay the same, right? My exponents don't change at all. So my x squared is still going to be x squared in the end. What's my coefficient going to be?
6.
No, negative 29.
We're not multiplying. We're just adding my like terms. So 7 minus 4.
Is
3 plus 1.
4.
So it's 4x squared. And then I have a 4x and a negative 3x. So that leaves me with what?
1x.
Okay. Positive?
Yes.
Okay. And I'm not going to write the 1 because it's invisible, right? You can, but you do not have to. Okay. And then lastly, I have a positive 1 and a positive 2.
Which is plus 3.
Plus 3. We're going to do that last one together as well. Do I have a matching term that matches 11yz squared?
Yes.
Which one is it?
That's 21 z.
The one in the middle?
No. Yeah.
Okay. 3yz squared. Okay. Your variables and your exponents have to match exactly. So 11 plus 3 is what? 14. My yz squared stays the same. Then I have a negative y squared z. Negative 3y squared z. Do I have another y squared z?
Yes.
Okay. So that is negative 8y squared z.
There's negative.
There's nothing else that matches that one, right? So it just gets, it's still there. It's just tacked on the end, right? So the next fill in the blanks, okay, to add polynomials, remove the parentheses and combine terms. Specifically, what kind of terms do we combine? We combine like terms. Okay. You cannot combine terms if they are not like terms. Okay. For vertical addition, which I've shown some of you guys, especially if you are in my homeroom, and I've showed you how to rearrange them when they're given to you horizontally, to rearrange them vertically to help you, okay, organize better. But you need to make sure, so make sure that you line them up right, just like we did when we did the elimination method, right? That's how we lined them up for the elimination method. We put them in vertical form so that we could eliminate things. So you can rewrite things that are in horizontal form as vertical form so that you can see what lines up better. Okay, so for vertical addition, make sure the terms are lined up by degree. That's that word that you needed to know. So they just need to be matching, lined up by the matching terms. Okay, so lined up by the matching terms. So we're not going to do all of these problems today. I'm trying to let y'all have some time to work through some of your homework problems at the end of class. So as that we work through these, okay, the quicker y'all participate, right, the quicker we can get through them. So if I'm adding two polynomials together, does that change anything behind the addition sign?
No.
No, so I can just ignore the parentheses, right? So I've got a 2x squared and an x squared. So 2x squared plus 1x squared is
3x squared.
3x squared. Then I have a positive x and another positive x, which is 2x. And then lastly, I've got a negative 5 and a positive 6. It's actually a positive 1. Positive 1. Because my 6 is bigger than my 5. Okay? So now if I line it up vertically, I'll try to do it where the cutter can see it a little bit there. Okay. If I line it up vertically, it would look something like this, right? Make sure that your y squares are lined up with your y squares and so on. So negative 4y squared plus 3y squared is a negative y squared, right? Negative 1, but negative y squared. And then my second terms there are both y's. So 3y minus 7y, negative 4y. And then lastly, I've got 6 plus 9.
3.
Positive 3, yes. Okay. So now look at this one right here. Why is there a blank here?
Because there wasn't an x.
There wasn't another x term in this polynomial. So a blank was left so that all of my ones that did match could be lined up. Right? So 2y cubed plus 2y cubed is what?
4y.
4y cubed. Okay? The letter and the variable, the variable and the exponents stay the same. They don't change. Then I've got nothing plus x, so that doesn't change. Then negative 4 and negative 3.
Negative 7.
Negative 7. Okay. Just like that. So you can take, if I have something that is written horizontally and I want to write it vertically, then all that you have to do is line things up when you're doing it. So rewrite 5x cubed plus 2x squared minus x plus 7. Okay? And match up, make sure my 3x squared goes underneath my other x squared. So plus 3x squared, okay, minus 4x plus 7. Okay? So now I have it organized where that I can see all my like terms and combine them. So there was nothing here. I had to blank here. So 5x cubed plus 5x squared. That has a 1 there. So negative 1 and negative 4 is negative 5x plus 14. So to me, that's a lot faster than drawing circles and squares and triangles. I don't know about you, and you can do it any way that you want. Either one of these methods is fine. Okay. To me, I make fewer mistakes when I line them up like this to combine. So go on to the next page. A few people still writing, so I'm going to go in just a second. Okay. So blanks at the top. Subtracting polynomials, distribute the minus like a negative 1. So we've done this. We've done this lots in here. So right here in front of this parentheses, this minus sign is like a negative 1 that I'm going to distribute. Okay. So negative 1 times 2x squared makes this a negative 2x squared. Negative 1 times negative 4x makes it a positive 4x. And a negative 1 times a positive 2 makes it a negative 2. Now I can go ahead and combine my like terms just like I was adding them. Okay, so I've got 3x squared and negative 2x squared. That gives me 1x squared. Now I've got 4x plus 4x plus 8x. And then negative 6 and negative 2.
It's
Mhm.
negative 7. Oh,
Negative 8.
what did I say? Oh.
Now I'm going to do the same thing for this minus sign right here. Okay, I'm going to distribute that minus sign as if it's a negative 1. But to do that, I'm going to go ahead and change this to a plus sign, and then I'm just going to change everything behind it to the opposite sign. And I'm going to make sure if I change it to a negative, that I make sure I don't misunderstand and think it's a positive. So notice how I made my negative sign cover up my positive sign completely there for that 9. Same here.
Why did he switch all the minus?
Because it was minus, like up here, right? And right
You
here,
gotta have.
we had to distribute it like a negative 1. And so since I had to distribute that negative 1 to everything, that means it changes the signs of everything. Because positive 3 times a negative 1 is going to make it negative 3. Negative 7 times positive 1 gives me positive 7. Multiplying anything by a negative 1 just changes its sign. Right? So now everything's lined up. I can just go ahead and work it out. Or combine my like terms. So negative 4y squared minus 3y squared.
Negative 7.
Negative 7y squared. Okay. Then I've got a positive 3y and a positive 7y. So a positive 10y. And then lastly, I've got negative 6 and negative 9.
Negative 15.
Negative 15.
Wait, was there words up here?
There was
Oh, I didn't.
distribute and negative 1. So again, if that, you have a negative out front here. Okay, if you are subtracting, change it to a plus sign and change all of the signs of the numbers only in that bottom because you're only subtracting things on the bottom. The reason this happens, let me erase that for a second. Okay, if I did 2y cubed minus, if I did 2y cubed minus 2y cubed, is that not the same thing as adding a negative 2y cubed?
Yeah.
It is, right? Because 2y cubed minus 2y cubed cancels out, doesn't it? Okay, so that would cancel. And doesn't 2y cubed plus a negative 2y cubed also cancel?
Yes.
Yes. Okay, so that's what we're doing when we're distributing that minus sign. We're just distributing it, so we're not having to remember 0 minus a positive x. Well, minus an x is negative x. So all we're doing is shifting that minus sign all the way to all your numbers, so you don't forget. Okay, so we've got negative x, and then we've got negative 4, and negative 3 is negative 7. Right? Did I change that sign wrong when I did that again? Oh, yep, I did, because that should be a plus. Sorry, that should be a plus sign. So this right here should be a negative 1, not a 7. So let's talk about a problem that looks like this. Again, here's my minus sign. Distribute that, so we've got negative 3x cubed, okay, because I'm distributing it, negative 4x, and a positive 5. Now I can combine all my like terms. So negative 2x cubed, negative 3x cubed, those are my only two, so I've got negative 5x cubed, negative 3x squared, and 4x squared is a 1x squared, plus 2x minus 4x minus 3x. What do I end up with? Negative 5x. And then lastly, I've got negative 5 and positive 5. What's going to happen with those? They're going to cancel out. Okay, so my final answer is this one. Now, if I wanted to rewrite this so that it was vertical, then I could. It would just be negative 2x cubed minus 3x squared plus 2x minus 5. When I rewrite this, I would go ahead and change my signs as I rewrite it. So it would be minus 3x squared cubed, sorry. I don't have an x squared term, so minus 4x, so I leave a blank, and plus 5. Then I don't have an x cubed, but I've got a 4x squared and a minus 3x. So now I can just combine like terms all the way down. Got negative 5x cubed plus x squared minus 5x, and then again, these cancel. Okay. So either way you do it is correct. Just briefly, I want to show this one right here. When you distribute this negative here, that was also a negative, so it's going to be a positive. Negative, negative. So everything changes signs when you distribute that negative sign. So if it's negative, it changes positive. If it's positive, it changes negative. So negative 2x plus x squared gives me a negative x squared. Positive 3x minus 3x, those cancel. 1, negative 1 and negative 1 is negative 2. We're on the next page. There's your blanks at the top. Okay, multiplying polynomials sounds scary, but we already know how to distribute. That's all we're doing. Okay. Multiply the term outside the parentheses by each term inside. Treat subtracted terms as adding a negative. When multiplying powers with the same base, add the exponents. Those are those exponent rules that we learned. Cutter and Joshua, get your head up so that I can see that you're taking notes. So when we distribute, we're going to take whatever's outside, the whole thing that's outside, and multiply by everything inside. So 3x times 2x squared gives me what? 6x cubed, right? Because we've got x to the 1 power times x squared. Right? So don't forget about that power of 1 that's out there on your x. So everybody got the fill in the blank so I can zoom in some? Okay. Then we've got 3x times negative 5x.
Negative 15.
Negative 15x to the second power squared. Yes. Okay. Then we've got 3x times 3.
9x.
If you do not have any like terms inside your parentheses when you start, you are not going to have any like terms when you finish distributing. So look at this one. This one has parentheses around this first term as well. It's still the thing that you're going to distribute to everything inside this parentheses because this is a monomial and you're going to distribute it to the polynomial. It's easier that way.
Isn't that a try?
That is a trinomial, yes. And this first one is a monomial, right? It's only got one term. So we've got negative 1/2 times 10.
Negative 5.
Negative 5. M squared times m to the 4th. M6, because 2 plus 4 is 6. What do I do with this n cubed? I still have to use it, right? It's still there. Okay. Now, negative 1/2, sorry, m squared times n cubed. So negative 1/2 times negative 8. positive 4. M squared times M, remember these have those 1s on them.
So 3
So M cubed, yep, and N,
and 4.
4, yep. Okay, and then lastly, we've got negative 1/2 times negative 2.
4? No.
1.
Positive 1. Okay, and M squared times N squared. Oh, that doesn't change, right? So that's still M
2.
squared. N cubed times N squared.
5.
Yeah. Okay. So even though I had a fraction and it looked kind of ugly, it wasn't really any more difficult than that first one that we did, right? Just a few more letters that you had to deal with. Okay. So the only other one that we're going to talk about is this one right here. So this is combining everything that we talked about today. So you have to distribute what's out front, and then you might have some like terms that you need to combine. So x times 2x is what?
3. 2.
1 times 2 is
2x.
still 2, but we've got x squared because they both have a 1 that we have to add for my exponents. Then I've got x times negative 5. Negative 5x, yep. Then I've got positive 4 times x squared.
X.
4x.
No.
4x squared. So which method do you like? Do you want to leave it horizontal, or at this point do you want to line them up vertically so that you've got your like terms?
Can you do horizontal?
I can. Okay, so you can do it like this, so it's all like that. Or you can line it up once you see, okay, that's going to be a like term for this first one, so I'm going to put it underneath of it so I can add it. And then 4 times 4x
16.
16x, and I could do it here, plus 16x. Okay, so if you like the vertical way, then when you start seeing like terms, start putting them underneath each other, collecting them that way. If you like the horizontal way, then just keep writing them out. Okay, either way is a correct way to do it. Now I need to finish combining my like terms though. So I've got 2x squared and 4x squared gives me 6x squared. Negative 5x and 16x gives me a positive 11x. So that would be my final answer after I simplified everything. Okay. So that's the end of our notes today. You guys got finished quicker than any of my other classes. So good job, guys. But I have an assignment I'm going to come around and bring to you. It does need to go in Go Formative.
How much time we got?